Hello everyone, and welcome to the doubly linked lists lecture. In the previous lecture, we implemented using Python nodes and created a singly linked list from those nodes. In this lecture, we'll talk about what doubly linked lists are, and then in the next lecture, we'll go over an implementation in Python of doubly linked lists. So as I mentioned, we're going to have an overview, and we're also going to focus on some specific topics that occur in a doubly linked list, known as header and trailer sentinels. Okay, so what is a doubly linked list? In a doubly linked list, we define a linked list in which each node keeps an explicit reference to the node before it and a reference to the node after it. These lists allow a greater variety of constant time update operations. This includes insertions and deletions. We continue to use the term next for the reference to the node that follows another. We'll have a new term, however, called previous, or PREV for short, for the reference to the node that precedes it. Okay, so we add special nodes at both the ends of the list, so that header and that trailer. A header node at the beginning of the list and a trailer node at the end of the list. You can check the diagram here. Note how this looks similar to that singly linked list, except now we're referencing previous lists as well, not just what comes next, but what was previous. These dummy nodes are known as the sentinels, or guards. So we have this header list, this header node, this header sentinel, and this trailer node, or trailer sentinel. Every insertion into our doubly linked lists representation will take place between a pair of existing nodes. When a new element is inserted at the front of the sequence, we simply add the new node between the header and the node that is currently after the header. So for instance, let's go ahead and take a look at what inserting and deleting would look like in a doubly linked list. Here in figure A at the top, we have our header sentinel, or trailer sentinel, and then 3 nodes. And note how they all point, at least all the nodes in the middle, point to a previous node and a next node. If we want to insert a new node, what we can do is just change the header, or the next pointer, and the previous pointer to accommodate the new node. So the steps are A, what it looks like before the operation, B, after creating this new node, and then C, after linking the neighbors to the new node, pointing the next and the previous to the corresponding nodes. Now imagine we wanted to insert a node to the front. What would this look like? It's actually a pretty similar process. This is what it looks like before the operation, after we create a new node, and then we just relink the header sentinel to that new node, as also the new node then points previous to the header node. And the similar situation happens to the node that it just replaced. The node that used to be at the front, right next to the header. Now let's talk about deleting a node. The 2 neighbors of the node to be deleted are linked directly to each other. As a result, that node will no longer be considered part of the list and it can be reclaimed by the system. Because of sentinels, the same implementation can be used when deleting the first or last element of a sequence. For example, here we have 3 figures. A is what it looks like before we actually delete a node. And if we want to delete a node, we just link the old node. So in this instance, we're linking out PVD. So we point JFK to SFO, and then that node, we say the previous node is actually JFK, no longer PVD. So all you have to do is just link out old nodes. Okay, so we learned about doubly linked list nodes, how they point to both what's coming up next and what came up previously. We learned about insertion and deletion. And now next we're going to implement a doubly linked list using node classes in Python. Okay, thanks everyone, and this will make a lot more sense when you actually see it coded out in the next lecture. I'll see you there.